Welcome to Just Around Earth, where curiosity finds a comfortable space and science unfolds at a gentle pace. Whether you're settling in for the night or allowing your thoughts to drift, it's wonderful to have you here. Tonight, let's embark on an intriguing question, one that doesn't have straightforward answers or tidy conclusions. Instead, it invites you to reconsider the solid ground beneath your feet. What if Earth were designed? Now, I'm not talking about a simple assembly, like picking out a flat-pack bookshelf. While the image of tiny cosmic tools is certainly amusing, I want to delve into a deeper idea. What if Earth is not merely the product of random events and indifferent physics, but rather shaped intentionally and systematically by some force or process? You might envision this as an intelligent creator, a complex simulation, a vast natural algorithm, or perhaps something entirely different. The interpretation is yours to explore. Our journey tonight isn't about debating this notion, it's about exploring it. Here, we embrace quiet questions rather than loud opinions, and we won't rush to find answers. Instead, we'll meander through this concept, paying attention to both the subtle details and the grand patterns that emerge. Along the way, you may find that simply asking this question opens up new perspectives on the world around you. So, let's take a moment to reflect together. Let's take a moment to explore something profound, something that might just change how you view your everyday life. Picture your typical day. You wake up to soft light streaming through your window, just the right temperature to start your morning. As you inhale, you fill your lungs with air that your body was perfectly designed to use. When thirst strikes, clear, essential water is right there, ready to quench it. Perhaps you step outside. You notice the plants, the animals, the sky above, the gentle temperature, and the force of gravity. Everything aligns just right, not only making life possible, but also comfortable. It's easy to overlook this comfort, isn't it? Most of us do, yet beneath that ease lies something worth contemplating. Is it all mere coincidence? Could it be? Or is there a deliberate arrangement, like puzzle pieces that fit together a bit too perfectly? Science has certainly provided us with an extensive understanding of the early solar system, planetary formation, and chemical evolution. We have developed models, collected data, and traced timelines that extend back billions of years. This framework is impressive. However, even within this robust system, there are elements that invite reflection, elements that seem, quite frankly, a little too convenient. As you ponder this, consider how it all connects. What do you think? You find yourself reflecting on the remarkable stability of Earth as it orbits a very stable star. This journey takes place in what we call the habitable zone, where water can exist as a liquid, an essential ingredient for life as we understand it. It feels fortunate, doesn't it? But there's so much more to consider. Think about the planet's tilt, which gives rise to our seasons, and its rotation speed, which prevents extreme temperature swings. The size of the moon plays a crucial role too, affecting tides and helping to stabilize that tilt. We also benefit from a magnetic field that shields us from harmful solar radiation. The composition of our atmosphere and the balance between land and ocean are equally vital. Each of these factors could have been dramatically different, and had they been, life as we know it may never have emerged. This concept is often referred to as the anthropic principle. It suggests that the universe appears tailored for life simply because we are here to witness it. If it weren't suitable for life, we wouldn't be around to ponder these questions in the first place. While this explanation might seem tidy, it invites deeper contemplation. Is it truly sufficient to say, we exist, so everything must have worked out? Or does this perspective skirt around something more profound? It's essential to recognize that none of this definitively proves a design behind our existence. Yet, the questions linger, inviting you to explore further. What do you think? Patterns may not definitively prove purpose, yet they often guide us toward it, inviting reflection. As you embark on this journey, consider these patterns not as believers or skeptics, but as curious explorers. Together, you will navigate through clues and coincidences, intertwining physics and philosophy, mathematics and metaphors. This exploration unfolds slowly, without the pressure to reach a single conclusion. Whether or not Earth was designed, it often behaves in ways that evoke the feeling of intention. This is not a definitive claim. Rather, it serves as an invitation to ponder what might change if it were indeed designed, and what aspects would remain constant. To delve into this, you will need to journey both wide and deep. Discussions will encompass planetary physics, biology, and chemistry, but will also extend to perception, narrative, and the reasons humans are captivated by the notion of a purposefully crafted world. While some of this fascination may stem from religious beliefs, it is far from exclusive to them. The instinct to gaze at the sky and sense a deeper meaning is likely woven into our very nature. Consider, for instance, your attraction to symmetry. You find beauty in faces, flowers, shells, and galaxies. When you encounter symmetry, your brain responds with excitement. What does this innate draw tell you about your relationship with the world around you? It feels just right, doesn't it? That feeling might not serve as proof, but it certainly provides a starting point for exploration. Have you ever wondered why a universe shaped by randomness continues to present us with such order? Why does our appreciation for beauty often align with what is efficient, functional, and mathematically elegant? This is where the journey gets fascinating. Even if you begin with a strictly scientific perspective, you'll find yourself immersed in questions that lean toward the philosophical. Consider biology. The more we uncover, the more we realize just how finely tuned many systems are. From the intricate folding of proteins to the way DNA encodes information and how cells communicate, everything is precise, interdependent, and in many instances remarkably efficient. Sure, it's not perfect. Evolution is often a messy process, leaving us with quirks and remnants, yet it works astonishingly well, and sometimes in ways that evoke the concept of design. Now, the term design can be quite loaded. It often conjures images of a conscious being sketching blueprints or fine-tuning molecules. But design can mean so much more. It can signify structure, intention, or a pattern that emerges not by chance, but with a sense of direction. Even if we don't understand the source of that direction, the notion that Earth is designed doesn't necessarily imply a specific designer. Isn't that a thought worth pondering? Imagine a universe shaped by intricate logic, where life-supporting outcomes emerge almost serendipitously. This leads us to ponder, could Earth be a selection from countless possibilities rather than a unique creation? Out of many potential worlds, perhaps ours was simply fortunate enough to nurture life. This thought prompts another intriguing question. How many possible Earths exist? Are we merely the lucky ones among a trillion? Or does the universe abound with worlds like ours, each showcasing its own unique stability and beauty? The truth remains elusive. As we venture into the realm of exoplanets, having discovered thousands, we are beginning to understand the rarity, or perhaps the commonality, of conditions similar to those on Earth. So far, however, none have matched our planet's delicate balance. We've encountered worlds that are too hot, too cold, too large, too dense, or overly exposed to radiation, Some lack atmospheres entirely, while others are engulfed in gas. Many orbit stars known for their violent flares. With each discovery, it becomes increasingly clear that Earth is indeed exceptional, not impossible, not one of a kind, but certainly not average. Yet defining average in such an expansive universe is a challenge. Perhaps the scarcity of Earth-like conditions is precisely what we would anticipate in a cosmos governed by chance. As you reflect on these ideas, consider how they shape your understanding of our place in the universe. Would you like to continue exploring these fascinating concepts, or perhaps take a moment to pause and ponder? Have you ever paused to think about the deeper implications of our existence? Perhaps it invites you to keep exploring the questions. Let's reflect on the concept of time, not merely as a measure of moments, but as a sequence that shapes life itself. Life required more than just the right elements. It needed the right timing. A stable planet was essential, yes, but so were billions of years of relatively peaceful cosmic conditions. Consider the rarity of asteroid impacts, the gentle rhythm of solar flares, and the presence of a moon that stabilizes our environment. Tectonic activity has played a crucial role in recycling carbon, and the atmosphere has evolved in precisely the ways that life has needed. All these factors had to align perfectly. While this might seem improbable, it adds another layer to a complex puzzle. Throughout history, people have sought to explain this phenomenon in various ways. Some view it as divine intervention, others as mere chance, while some believe it to be an inevitable outcome given sufficient time and space. The notion that Earth may have been intentionally arranged, either directly or through some intricate natural laws, remains intriguing. It's not about proving a point, but rather about how it resonates with our experiences. As beings who create, plan, and envision outcomes, it's only natural to wonder if our world, which appears so meticulously organized, was crafted by something or someone. Yet, as we ponder these thoughts, it's important to approach them with care and reflection. Patterns can emerge from randomness, and perception can sometimes lead us astray. Just because something appears to be designed doesn't necessarily mean it is. Similarly, the unlikely doesn't always indicate intention. Yet the converse holds true as well. Just because science can shed light on how something occurred doesn't mean we grasp the full extent of why it happened, or if a deeper structure exists beneath the surface. The question we're exploring isn't about refuting science or validating belief. Instead, it's about creating a space where both can approach the same inquiry from different perspectives. What changes in our understanding? What remains constant? And what implications does this have for our lives, our relationships, and our path forward? As we delve deeper, we will examine specific elements of Earth that frequently arise in these discussions. We'll consider the orbital sweet spot, the moon's remarkable influence, the delicate balance of our atmosphere, the intricate details of DNA, and the myriad systems that had to harmonize for intelligent life to flourish. Each of these topics invites a multitude of questions, not only regarding science, but also about our expectations of reality itself. When we ponder whether Earth was designed, we are not merely contemplating planets or the laws of physics. We are touching on something much more profound. This question, beneath all its scientific layers, is deeply personal. It invites you to reflect on your place in the universe. Do you view life as a random occurrence that just happened to fall into place, or do you sense a more intentional design behind it? When you consider whether Earth was created with purpose, you venture into a conversation that transcends mere facts. Unlike inquiries about volcanoes or the changing of seasons, which are fascinating yet detached, this question stirs something within. It connects you to a much older dialogue, one that predates modern science, spanning back to when humanity first gazed at the stars and pondered the significance of existence. This line of questioning is woven into philosophy, religion, and mythology, stories of the earth shaped by divine hands or sacred voices that brought the world into being. Though these narratives may conflict in their specifics, they share a crucial insight. They echo a fundamental human instinct, the desire to intertwine what is with what matters, to transform mere facts into a sense of purpose. This instinct is valuable and worthy of your attention. As you explore these thoughts, consider how they resonate with your own beliefs and experiences. Would you like to continue this journey of reflection, or take a moment to pause? It's easy to think of science and meaning as two separate realms. One explains how things work, while the other delves into why they matter. Yet the distinction often blurs. As you deepen your understanding of the universe, you begin to notice moments where structure and outcome align in ways that feel almost purposeful. Consider carbon, for instance. Life on Earth fundamentally revolves around this single element. Carbon is the backbone of DNA, proteins, and the intricate chemistry that fuels cellular activity. Its versatility is remarkable. It forms bonds effortlessly, creates long chains, and generates stable molecules capable of carrying information and building structure. Without carbon, life as we know it simply wouldn't exist. When you explore how stars produce elements, you discover that carbon emerges from a very specific set of conditions. If the physics of fusion had been even slightly different, either a bit stronger or a touch weaker, the universe might be filled with hydrogen and helium, but devoid of carbon. Without carbon, there would be no life, no you. Such coincidences prompt reflection, not because they prove anything definitive, but because they highlight how precise conditions must be. The more you uncover about the laws of physics, the clearer it becomes that values like mass, charge, gravity, and the strength of forces had to fall within very narrow ranges for complex matter to come into being at all. As you ponder these connections, consider the wonder of existence itself. What does it mean for you to be part of a universe where such intricacies align? Consider the vastness of existence, life, stars, planets, and the intricate dance of chemistry. This phenomenon is often referred to as fine-tuning. It invites a profound question that lingers behind much of modern science. Why these specific numbers? Why this particular version of reality? One possible explanation is the concept of the multiverse. Imagine countless universes, each governed by its own unique set of physical constants, with ours being the one where everything aligns perfectly. This notion seems plausible, yet we lack direct evidence of these other universes, at least for now. Even if we were to discover them, it would still leave us pondering why our universe is structured the way it is. It merely shifts the question further back. Another perspective suggests that these values may not be the result of selection at all. Perhaps they are simply inherent in a deeper framework we have yet to uncover. This too remains a mystery. Regardless of the explanation, we find ourselves in a reality where things had to be a certain way, and indeed they are. This leads us to an even deeper inquiry. It's not just about why Earth is as it is, but why anything exists at all. Why do the laws of physics exist? Why should there be a universe filled with rules, structure, patterns, and matter? Why is there something rather than nothing? These are profound questions that no telescope can answer. Take a moment to reflect on these mysteries. What thoughts do they stir within you? You find yourself drawn back to this idea repeatedly. It's worth noting that science doesn't require a sense of purpose to function. You can study gravity without contemplating its origin. You can analyze DNA without questioning who authored it. However, science doesn't dismiss those inquiries. It simply operates independently of them. For some, this creates a middle ground, a space where you can engage with the world through empirical evidence, while also allowing for the possibility that there is more at play than what we can quantify. This is where design enters the discussion. It doesn't aim to replace science, but rather offers a perspective, a lens through which to view the world. It encourages you to continue asking questions, especially when you encounter something that seems deliberately arranged. The fine-tuning itself invites your attention, suggesting that it might hint at something deeper. Naturally, not everyone shares the same interpretation of that deeper significance. Some envision a conscious designer, perhaps a god, an architect, or an intentional being. Others perceive an inherent intelligence within the universe, not as a singular entity, but as a process that naturally strives toward order, beauty, or complexity. Then, there are those who regard design as a human construct, a narrative we impose on our surroundings because we are instinctively inclined to seek patterns and stories. As you contemplate these perspectives, what resonates most with you? Every perspective you explore brings forth the same question, yet the answers may vary. This question lingers quietly behind every action we take. Each scientific discovery, every new satellite image, every equation or theory is framed by the remarkable fact that you are here, observing. There is something to behold, and it behaves in ways you can comprehend. Pause for a moment and reflect on this. It's not just that the world exists, it's that it's understandable. You can measure it, predict it, and explain it. Your brain, which evolved from ancient systems designed for survival, now models galaxies, constructs computers, and ponders the universe's purpose. Why is it that a species on a small rock in a distant corner of a galaxy can grasp the rules that govern space and time? This thought doesn't prove anything, but it's certainly intriguing. It prompts you to wonder if your capacity to understand the universe is part of a more extensive pattern. Perhaps the universe is not only structured, but designed in a way that invites comprehension. This isn't a claim, it's merely a contemplation. Ultimately, these questions need not feel threatening. They don't detract from the essence of science. Instead, they enrich it. Science invites you to the edge of mystery and encourages you to venture further. You don't have to solve every question for it to hold significance. Sometimes, simply holding on to a question is enough. This concept, that the world may have been built, arranged, or shaped in some manner, has long intrigued humanity. It's an ancient inquiry that feels remarkably modern today. With our advanced tools, we can investigate the fundamental components of matter, the forces that govern nature, and the intricacies of life itself. As you delve deeper, the questions only become more profound. This isn't due to a lack of answers, but rather because the answers we uncover are incredibly detailed, precise, and delicately balanced. They prompt you to reflect. Is this merely what happened to work, or is it what was meant to unfold? While we may never fully grasp this, the pursuit of understanding keeps us engaged. We can continue to explore the structure, order, and logic of our world, not to prove anything, but to gain insight. In doing so, you may find yourself inching closer to the essence of it all. When you begin to examine Earth, not only in the context of the cosmos, but also its surface, systems, and the everyday materials beneath your feet, you start to recognize certain patterns emerging. Have you ever paused to consider the intricate dance of our planet? Some patterns in nature are geological, others chemical, and some mathematical or structural. As you delve deeper, You might find these patterns appear almost intentional. Let's start with the basics. The Earth's crust is made up of plates that float on a hotter, softer layer known as the mantle. Over time, these plates shift and slide, giving rise to mountains, earthquakes, volcanoes, and even oceans. Imagine if plate tectonics didn't exist. The Earth's surface would be flat and static, eroded away over time. Nutrients would stagnate, and life as we know it might never have emerged. This movement of the plates is crucial for regulating carbon. When volcanoes erupt, they release carbon dioxide into the atmosphere. Conversely, as mountains weather, they draw carbon dioxide back down. This delicate balance influences our climate, which in turn shapes the entire biosphere. Science has meticulously mapped out these processes, yet when you step back and observe the broader picture, it's fascinating to think about how many ways this system could have faltered. The planet required not just a solid crust, but one that could crack, float, and move. If the crust had been too thick or the mantle too rigid, those vital shifts wouldn't occur. Conversely, if it had been too active, the surface could have been constantly reshaped, leaving no room for life to find its footing. Isn't it remarkable to reflect on the delicate balance that sustains life on our planet? As you ponder this, consider how interconnected everything truly is. Imagine Earth as a delicate balance, resting comfortably in the middle of calm and chaos. As you explore this idea, you'll notice how it applies to many aspects of our world. Take soil, for example. It's a fascinating blend of minerals, organic matter, water, and air. Yet the right balance is crucial. If there's too much sand, water drains too quickly. If there's too much clay, roots struggle to breathe. The most fruitful soils, those that nurture forests, crops, and vibrant ecosystems, maintain a careful equilibrium. This balance may differ from one region to another, but it consistently falls within a narrow range of characteristics. Plants have evolved to thrive in these specific conditions, or perhaps it's the other way around. This concept of coevolution is prevalent, extending beyond just plants and soil. It includes insects and flowers, fungi and trees, bacteria and animals, systems that not only function but also collaborate. Each component is shaped by the presence of the others, creating an intricate web of life. Sometimes, this connection feels less like adaptation and more like assembly. Consider a seed, for instance. It holds everything necessary for growth: the instructions, the energy, the structure. It lies in the soil, patiently responding to moisture, temperature, and light. When these conditions align perfectly, it undergoes a remarkable transformation. Roots extend downwards, while stems reach upwards, embodying the essence of growth and connection. As you reflect on these relationships, what do you think about the interconnectedness of life? This dance of balance and coevolution invites you to appreciate the intricate systems that surround us. Would you like to continue exploring this theme, or perhaps take a moment to ponder it in stillness? Imagine a fascinating process that unfolds in nature, one we can describe in biological terms. The timing, sensitivity, and precision involved are truly remarkable. Consider the shape of seeds and how they travel. Some stick, some sink, and others float. It all seems remarkably optimized. While it's tempting to attribute this to natural selection, where successful traits endure and unsuccessful ones fade, it's important to remember that selection acts on what already exists. It doesn't create from nothing, it repurposes, adjusts, and refines. This brings us to the significance of the starting materials, the fundamental building blocks of life. Carbon, nitrogen, oxygen, and hydrogen are not just abundant, they are incredibly versatile. They bond effortlessly, store energy efficiently, and form the types of molecules that can loop, twist, and replicate. While some of this is rooted in chemistry, even chemistry adheres to certain rules. Interestingly, those rules in our universe seem to favor complexity. This doesn't imply that complexity is guaranteed, but once it begins, there is ample room for growth. Take water, for example. It is neither a metal nor a gas, nor is it particularly rare, yet it possesses a remarkable array of unusual properties. As you reflect on these elements, consider how they contribute to the intricate tapestry of life around you. This exploration invites you to ponder the wonders of nature and the building blocks that have shaped our world. Imagine a world where water behaves in fascinating ways, expanding when it freezes. This unique property allows ice to float, creating a lifeline for organisms beneath frozen lakes. Water also possesses a high specific heat, which helps regulate temperature, making it a stable environment for life. It can dissolve more substances than nearly any other liquid, serving as the perfect medium for countless chemical reactions. All these remarkable traits stem from the specific angle formed between two hydrogen atoms and one oxygen atom. If that angle were just a bit different, water would behave entirely differently, and so would everything that relies on it. Now, let's delve into the intriguing concept of fractals, patterns that repeat at various scales. You can observe them in river networks, mountain ranges, coastlines, tree branches, and even in our blood vessels. These shapes are not merely beautiful, they are also incredibly efficient. For instance, trees transport nutrients from their roots to leaves through fractal branching, while our lungs utilize a similar system to move air. These forms are not random, they adhere to specific mathematical principles. These principles emerge independently across different systems, a phenomenon some refer to as convergence, while others may see a more intentional design. Consider the Fibonacci sequence, a spiral pattern that appears in shells, pine cones, sunflowers, and even galaxies. Isn't it fascinating how these mathematical rules manifest in so many aspects of our world? As you reflect on this, you might wonder about the deeper connections that bind everything together. The beauty of nature invites us to explore further, urging us to continue this journey of discovery. You might notice that while not universal, certain patterns frequently emerge, especially in the context of growth. This phenomenon allows for efficient packing and expansion. Interestingly, there's a mathematical underpinning to it all. The presence of mathematics in biology invites reflection. It's fascinating to consider that living organisms, shaped by random processes over millions of years, often align with principles we find both beautiful and logical. This observation raises a profound question. Does the universe adhere to mathematical principles out of necessity, or does mathematics articulate its nature so effectively because both originate from a shared source? This inquiry extends beyond mere philosophy. It has significant implications for our understanding of structure. If life emerges from patterns that adhere to specific rules, we must ask where those rules originate. This leads us to the concept of blueprints, not in the traditional sense of schematics, but as consistent systems that generate outcomes. The world around us is neither random nor entirely chaotic. Instead, it reveals an underlying order, a layered functionality. From the chemistry of soil to the movements of planets, we observe behaviors that are regular, testable, and repeatable. This consistency is the foundation of scientific inquiry. Yet it also prompts a deeper curiosity. Does this regularity hint at something greater behind it all? As you ponder these questions, allow yourself to explore the connections and implications they hold for our understanding of life and the universe. Patterns can emerge from chaos, and that's a fascinating truth. You've likely seen this in simulations and models, where subtle adjustments to initial conditions can lead to drastically different outcomes. This prompts an intriguing question. What were the initial conditions that led to our world? Why do we have these specific laws and structures? Consider how minerals form crystals, how plants respond to light, or how animals evolve the ability to see. This isn't an argument for the supernatural. However, as you delve deeper into the Earth's structure, the blueprints hidden in its soil, its intricate systems and cycles, you can't help but wonder, could this all have been organized? Not by magic or miracle, but perhaps by a process that remains elusive to us. A process that embodies design, not as a result of conscious choice, but as a natural inclination towards systems that promote life. At this moment, you don't need to reach a conclusion. This journey isn't about finding answers, it's about observation. And what you're discovering is that the Earth is not a random assortment of elements. Instead, it reveals itself as a deeply interconnected system, rich with rules, balances, and alignments that appear to favor stability, growth, and resilience. It's important to acknowledge that while it may not be perfect, it functions remarkably well, often in ways that feel surprisingly harmonious. When you think about why life thrives on Earth but not on Mars or Venus, you might come across the term Goldilocks zone. This nickname refers to the region around a star where temperatures are just right, not too hot, not too cold for liquid water to exist. Since water is essential for all known forms of life, the idea is that any planet situated comfortably within this zone has a chance to support life. Earth finds itself perfectly positioned in this range, close enough to the sun to remain warm, but far enough to avoid boiling. The sun itself is stable and long-lived, allowing our planet billions of years to nurture complex ecosystems. It's easy to feel a sense of satisfaction from this understanding, almost as if the universe played a precise game of darts and hit the bullseye. However, as you delve deeper, the situation becomes more intricate. The habitable zone is not a fixed area. It varies depending on the size and brightness of the star. A smaller, dimmer star has a tighter Goldilocks zone, while a larger, hotter star pushes this zone further out. This might seem balanced, but each scenario introduces its own set of challenges. For instance, smaller stars often experience flares, releasing bursts of radiation that can strip away a planet's atmosphere. Reflect on this. How might these differences in stars influence the potential for life elsewhere in the universe? Imagine a universe where the stars shine brightly, yet some burn out quickly, leaving little time for life to flourish. Our sun, however, is a remarkable exception. It stands as an average star, stable, bright, and long-lived. While it may not be the sole type of star capable of supporting life, it certainly ranks among the best. Now consider Earth's orbit. It doesn't just float aimlessly in space. It maintains a steady path around the sun. This orbit is nearly circular, which means the solar energy we receive remains fairly consistent throughout the year. Some variation is essential, as it gives rise to our beloved seasons. However, excessive fluctuations would lead to extreme climate conditions. A slightly more elliptical orbit could have rendered vast regions of our planet uninhabitable. Yet here we are with a gentle wobble and a tilt that stirs our atmosphere just enough to create balance without chaos. But let's not forget that distance and orbit are merely the foundation. A planet can exist within the habitable zone and still be devoid of life. Take Mars, for instance. It lies on the outer edge of the Goldilocks zone. While it possesses ice and may have once had water, it is now a cold, dry wasteland, vulnerable to radiation. The reason for this desolation? Mars lost its magnetic field, taking much of its atmosphere with it. Without that protective shield, the planet lacks warmth, pressure, and safety. So, as you ponder the delicate balance that allows life to thrive on Earth, consider the intricate dance of distance, orbit, and the vital conditions that nurture our existence. Would you like to explore more about what makes our planet so unique? You find yourself pondering the delicate balance of our planet. Imagine Venus sitting just inside the inner edge of the habitable zone. It's similar in size and composition to Earth, yet its atmosphere is thick with carbon dioxide, leading to a runaway greenhouse effect. The surface temperatures soar high enough to melt lead, and the clouds are composed of sulfuric acid. If Earth is a warm cup of tea, then Venus is like a boiling kettle, perpetually screaming. This stark contrast highlights how unique Earth truly is. Our planet exists in a narrow window, not only in terms of distance from the sun, but also in how its systems harmonize. The atmosphere is thick enough to trap some heat, yet not excessively so. It contains just the right mix of oxygen, nitrogen, and carbon dioxide. Our oceans play a crucial role in moderating the climate, while weather systems effectively distribute heat across the globe. The greenhouse effect is present, but it remains in check. For now, this balance isn't fragile, it's dynamic. It shifts, adjusts, and compensates. When one aspect changes, other parts respond, reinforcing the system's stability. Yet, it's intriguing to think about how different things could have been. Small variations in early conditions might have led to a planet that looks completely different today. What if? These reflections invite you to appreciate the intricate dance of elements that sustain life on Earth. Would you like to explore more about this fascinating balance? Imagine rewinding the clock to the very beginning of our solar system. Picture a swirling cloud of gas and dust, the birthplace of the sun and its planets. Within this cosmic cloud, Earth's position was shaped by a blend of gravitational pulls, collisions, and leftover materials. It might have formed further out, becoming a frozen rock, or closer in, potentially resembling Mercury. Yet, it found its place in the zone where water can remain liquid, allowing life the chance to emerge. Some view this as mere chance, a series of random cosmic events. That perspective is certainly valid. However, others gaze upon the outcome. Our planet, with its perfect temperatures, ideal chemistry, and rich history, and ponder whether the dice were somehow loaded. Not in a way that's unfair, but perhaps in a manner that suggests a certain direction. It raises intriguing questions. Is the Goldilocks zone a unique characteristic, or is it more common than we think? Do other stars host planets within the right range? Interestingly, the answer appears to be yes, at least in theory. Thousands of exoplanets have been discovered, and many of them reside in their stars' habitable zones. This realization opens up a world of possibilities and invites deeper exploration into the cosmos. What do you think? Are we alone, or is there more life out there waiting to be found? You find yourself pondering the mysteries of distant worlds. We still have so much to learn about these celestial bodies. Do they have atmospheres? Is there water? What about magnetic fields? You wonder if their climates are stable or tumultuous. Beneath their surfaces, what secrets lie hidden? Even if we discover a planet with the right ingredients for life, can we be certain that those ingredients ever came together to create it? For now, Earth remains our most compelling example. The more we explore it, the more intricate and finely tuned it appears. It's not without its flaws. Climates change, natural disasters strike, and ecosystems can falter. Yet through it all, balance remains. Life continues to thrive, not just in its simplest forms, but in complex and conscious ways. You may find yourself questioning how it all came to be. The phrase "just right" might sound straightforward, but it encompasses a multitude of interconnected systems. Geology, weather, magnetism, chemistry, and biology all interact in ways that nurture life's existence. It's not merely about location, it's about everything that location enables. Still, even this delicate balance might not be enough to draw definitive conclusions. Perhaps it's just a fortunate occurrence. Maybe life is rare, but not impossible. Earth is simply one instance where conditions align just so. This is the prevailing scientific perspective. Yet, beneath that, there lingers a quiet, persistent feeling, an intuition that this alignment transcends mere chance. Imagine for a moment that the universe has a design, a purpose that it strives to fulfill. What might that design be aiming for? Perhaps it seeks life, complexity, or simply balance, a system that holds itself together long enough to become truly fascinating. This doesn't imply that everything is perfect or easy. Earth is not a utopia, yet it is uniquely positioned for something rare and intricate to unfold. When you shift your focus from where Earth is located in the cosmos to what Earth actually is, the very structure of the planet becomes part of its narrative. It's not solely about the surface or the land we tread upon. It encompasses everything from its iron core to the shape of its orbit. If Earth was intended to nurture life, then its structure must surely be integral to that design. Even if there was no deliberate intention behind it, the arrangement of Earth's components prompts intriguing questions. Consider the heart of the Earth. Its core, primarily composed of iron and nickel, is divided into two distinct parts, a solid inner core and a liquid outer core. The movement of this outer core generates Earth's magnetic field, which acts as a protective shield against solar and cosmic radiation. Without this magnetic field, the planet would face relentless bombardment from charged particles, which could strip away the atmosphere, damage DNA, and render life not just difficult, but perhaps impossible. As you reflect on these ideas, what do you think about the intricate balance that allows life to thrive here? The magnetic field surrounding our planet is not merely a backdrop, it is the result of an intricate process known as the geodynamo. As the Earth rotates, liquid metal within its core swirls, creating electric currents that generate this protective magnetic field. For this remarkable system to function, several conditions must be met. First, the right materials are essential. The Earth requires a specific amount of internal heat, which originates from radioactive decay and the residual energy from its formation. Additionally, size matters. Smaller planets tend to cool too quickly, disrupting the necessary dynamics. Rotation is also critical, but it must be balanced. The Earth spins once every 24 hours, a pace that keeps its core active while maintaining stability on the surface. Imagine altering any of these factors. If the planet were slightly smaller, or rotated more slowly, or if it contained less metal, the entire magnetic system could falter. This scenario is reminiscent of Mars. In its early days, Mars likely possessed a magnetic field, but it cooled too rapidly. As a result, its core ceased to churn, and the protective shield vanished. What followed was a gradual loss of its atmosphere and surface water. Above this core lies the mantle, which moves slowly over time. This movement drives the tectonic plates on the Earth's surface. which, as we've discussed, play a crucial role in shaping our planet. You find yourself immersed in the intricate processes of our planet. Earth is a master at recycling minerals, shaping continents, building mountains, and regulating the carbon cycle. Yet, this remarkable system requires just the right amount of heat and a delicate balance between rigidity and movement. Imagine if the mantle were too soft, the crust would be constantly breaking apart. Conversely, if it were too stiff, nothing would shift at all. Fortunately, Earth seems to have struck the perfect balance. It remains dynamic without tipping into instability. As time passes, continents drift, collide, break apart, and reform. This movement influences climate, creates new environments, and helps isolate ecosystems, which is crucial for biological diversity. It's fascinating to consider how this process has led to the evolution of countless forms of life in various regions. Without such movement, our planet's surface might appear uniform and stagnant. Even the crust plays a vital role in this grand design. Though it is thin compared to the rest of the planet, only a few kilometers deep beneath the oceans, and somewhat thicker under the continents, it is where all surface life thrives. The composition of the crust is rich in essential elements for life: carbon, phosphorus, sulfur, calcium, and potassium. Interestingly, not all of these elements originated from Earth's initial materials. Many were delivered during a period known as the Late Heavy Bombardment, when asteroids and comets brought organic molecules, water, and other building blocks to our planet. Take a moment to reflect on this incredible interplay of forces. Isn't it remarkable how interconnected everything is? As you ponder this, consider how these elements and movements continue to shape the world around you. Imagine how different our world could be. With too many impacts, the surface of our planet might never have cooled. Conversely, too few could have meant that Earth lacked the essential ingredients for life. Yet, it seems that Earth received just the right balance, a blend of rocky and icy bodies that enriched what was already present. It's a remarkable moment in time where everything aligned against the odds. Surrounding this dynamic planet is its atmosphere, serving as both a protective barrier and a vital support system. It maintains warmth, shields against smaller space debris, and contains the gases necessary for life, such as those needed for respiration and photosynthesis. However, this was not always the case. In its infancy, the atmosphere was likely dominated by carbon dioxide, methane, and ammonia substances, toxic to modern animals, but crucial for early microbial life. Over time, photosynthetic organisms emerged, producing oxygen and gradually transforming the atmosphere into what we recognize today. This pivotal shift, known as the Great Oxygenation Event, could have unfolded in many ways. Oxygen is a reactive element. In high concentrations, it can be harmful. Yet, in balanced amounts, it enables complex metabolism, which in turn supports multicellular life. The resilience of Earth's systems during this transformation is a testament to the intricate feedback loops, both positive and negative, that kept conditions within a suitable range. Reflect on how these delicate balances have shaped our existence. Isn't it fascinating to consider the forces that have brought us to this moment? Imagine the delicate balance between carbon dioxide and oxygen, a dance orchestrated by living systems. Forests, oceans, and soil serve as essential carbon sinks, while volcanic activity and respiration release gases back into the atmosphere. Though this process may not create perfect equilibrium, it fosters a self-adjusting system that evolves over long periods. In this way, Earth resembles a living organism, responsive, flexible, and perpetually adapting. Now consider water. Its distribution across the planet may not be uniform, but it is remarkably effective. About 70% of the Earth's surface is covered by oceans, which play a crucial role in regulating temperature and circulating nutrients. Fresh water can be found in rivers, lakes, ice, and underground aquifers, creating a vital mix that sustains both marine and terrestrial life. This intricate system relies on a cycle of rainfall, evaporation, and flow, all influenced by geography and solar energy. Furthermore, the planet's tilt, approximately 23.5 degrees, determines how sunlight reaches different regions, giving rise to seasonal cycles. This tilt is stabilized by the moon, a topic we will explore in greater detail shortly. Without the moon's influence, the tilt could wobble unpredictably, leading to drastic climate changes in a short time. Instead, we enjoy a consistent rhythm that life has adapted to: migrations, hibernations, and flowering times, all synchronized with the angle of sunlight and the arc of the year. As you reflect on this intricate web of life, consider how each element plays its part in maintaining the balance we often take for granted. Wouldn't it be fascinating to delve deeper into these connections? Imagine piecing together a puzzle where each element reveals not just a simple image, but a complex, layered system. This system generates its own magnetic field, regulates its temperature, cycles its resources, and nurtures life. Picture a planet that creates and maintains the conditions necessary for existence through intricate feedback and flow. What if we shifted our perspective? Instead of viewing Earth as merely a fortunate collection of traits, you might begin to see it as a place governed by an internal logic. This isn't necessarily an external logic imposed upon it. Rather, it's a natural order that fosters life-sustaining outcomes. The question remains, did this logic develop over time, or is it part of a broader framework we have yet to fully understand? Now, consider the moon. It hangs in the sky each night, yet it possesses an intriguing strangeness. Its size relative to Earth is remarkable, and its gravitational influence shapes our oceans. The moon's role in stabilizing our planet is far more significant than a mere byproduct of cosmic forces. In fact, it may be one of the key reasons life has thrived on Earth for so long. At first glance, the moon appears to be a natural companion, a product of the very forces that sculpted our solar system. But as you delve deeper, the mysteries surrounding it beckon you to explore further. Would you like to continue this journey of discovery? When scientists began to investigate more closely, they discovered that explaining the moon's existence is more complex than it initially seems. The prevailing theory suggests that the moon formed from a colossal collision. An object, often called Theia, is thought to have collided with the early Earth. This impact would have ejected vast amounts of material into orbit, which eventually coalesced to form the moon. This theory accounts for the striking similarities between the moon's composition and Earth's outer layers, as well as the moon's relatively close and stable orbit. It aligns with our understanding of how early solar system bodies formed and interacted. However, this explanation hinges on a very specific set of conditions. The colliding object had to be large enough to propel material into orbit, but not so massive that it would obliterate Earth entirely. The angle of the impact needed to be just right, a glancing blow rather than a direct hit. Additionally, the ejected materials had to come together rather than scatter into space. Afterward, the system had to stabilize into an orbit that could endure for billions of years. This presents a narrow margin for success. With even slightly different speed or trajectory, Earth might have ended up without a moon, or perhaps with a chaotic ring of debris, or even an unstable secondary body that could have eventually crashed back down. Isn't it fascinating to consider how such delicate balances shaped our celestial neighborhood? As you reflect on these intricate dynamics, you might find yourself pondering the wonders of our universe. Feel free to take a moment to marvel at how interconnected everything truly is. Imagine a world where the moon isn't just a distant orb in the night sky, but a vital partner in Earth's delicate balance. You see, we have one large moon, perfectly synchronized with its orbit. It always presents the same face to us, positioned at just the right distance to create meaningful effects without throwing our planet off course. These effects are more significant than you might think. The moon plays a crucial role in stabilizing Earth's axial tilt. Without its gravitational influence, our planet's tilt could fluctuate wildly, swinging from almost zero to extreme angles. Such drastic changes would lead to unpredictable climate shifts. Seasons might become erratic or even vanish altogether. Areas that currently enjoy temperate climates could turn into frozen wastelands or sweltering deserts, only to revert once again. This kind of environmental instability would challenge ecosystems, making it difficult for them to adapt and thrive over the long haul. The moon's gravitational pull is also responsible for driving the tides. These tides are essential for coastal ecosystems, moving nutrients, regulating temperatures in shallow waters, and possibly even playing a key role in the origin of life itself. They create cycles of wet and dry that encourage chemical reactions crucial for life. The rhythmic ebb and flow of the oceans are not just background noise. They shape coastlines, influence weather patterns, and affect the behavior of countless species. As you reflect on the moon's influence, consider how interconnected everything truly is. Its presence is a gentle reminder of the balance that sustains life on Earth. Would you like to explore more about how these cosmic relationships impact our world? Imagine the subtle influence of the moon on our planet. Did you know that its gravitational pull is causing Earth to slow down, ever so gradually? A few billion years ago, our days were much shorter, lasting only about 6 hours. Over time, due to tidal friction, this has stretched to the 24-hour cycle we experience today. This process continues, albeit at a rate so small that you wouldn't notice it in your lifetime. Yet, this gradual slowing may have played a role in stabilizing our planet's climate. Now, consider the moon's role in the natural rhythms of life. Many organisms rely on the lunar cycle as a sort of biological clock, timing their migration, reproduction, feeding, and even sleep. For instance, coral reefs synchronize their spawning with the moonlight. Insects navigate by its glow, and even predators and their prey adjust their activities in response to how bright the night sky is. The moon creates a rhythm that is deeply embedded in the biology of countless species. And it's fascinating to think that all this comes from an object that by some estimate shouldn't even exist. Large moons like ours are actually quite rare among rocky planets. Take Mars, for example. It has 2 small, irregular moons that are likely captured asteroids. Mercury and Venus don't have any moons at all. In fact, our current understanding of planet formation suggests that large moons aren't a guaranteed outcome. As you reflect on the moon's influence, perhaps you might consider how interconnected life truly is, woven together by the gentle pull of this celestial body. Would you like to explore more about our relationship with the cosmos? Isn't it fascinating how unique our planet is? Earth possesses a moon that seems almost tailor-made for its role. This leads to an intriguing question. How did we end up with such a remarkable setup? While no one suggests that the moon was crafted with tools or blueprints, its presence creates a stable, life-supporting environment that's hard to overlook. The moon's formation, its orbit, and its influence on Earth all contribute to this mystery. Some believe that even without the moon, life could still have emerged in some form. However, the evolution of complex multicellular life might have faced significant challenges in a more chaotic climate. Imagine the struggle of intelligent organisms trying to thrive without the stability that our moon provides. Adapting to seasonal changes is one thing, but enduring a climate with extreme fluctuations over thousands of years is quite another. If you view the moon as a mere coincidence, it becomes an impressive anomaly. Yet when you consider it as part of a broader cosmic structure, it fits remarkably well into the larger picture of what makes Earth unique. There are also more speculative theories regarding the moon's role, inviting us to ponder even deeper. Would you like to explore these ideas further? Some people believe that the moon has played a crucial role in protecting Earth from asteroid impacts by changing the trajectory of incoming objects. Others suggest that its presence may have influenced the distribution of heat within Earth's core, impacting the geodynamo that generates our magnetic field. While these ideas are challenging to validate, they highlight an increasing recognition that the moon is not merely a passive companion, it is an active participant in Earth's history. Right now, the moon is slowly drifting away from Earth at a rate of about 4 centimeters each year. This change may seem insignificant on a human timescale, but over geological periods, it accumulates. In a few billion years, total solar eclipses where the moon perfectly obscures the sun will cease to occur. The moon will be too distant to appear the same size in our sky. This current alignment, like many aspects of Earth, exists within a limited time frame. It is not permanent, but it is long enough to matter. Gravity often goes unnoticed. It is a constant force, always at work, yet rarely acknowledged. You might not think about it until something falls, or you step on a scale, or perhaps when your coffee tips over, reminding you that even invisible forces have their way. However, when it comes to forming a planet and maintaining everything on it, gravity is far more than just background noise. It is a fundamental force that shapes our very existence. As you reflect on these concepts, consider how the moon and gravity are intertwined in the story of our planet. They remind us of the delicate balance that sustains life and the ever-changing nature of our universe. Would you like to explore more about these fascinating dynamics? Consider the unseen forces that shape our world. Gravity, while not the strongest force in the universe, possesses a unique power. It may be weaker than electromagnetism or nuclear forces, yet a small magnet can effortlessly lift a paperclip against the immense gravitational pull of our planet. What gravity lacks in strength, it compensates for with its relentless reach. It is always present, never blocked, and acts upon everything that has mass. This quiet persistence is what makes gravity an extraordinary organizer. Without it, Earth wouldn't take on its familiar spherical shape. It wouldn't even exist as a planet. The matter that eventually formed Earth would still be scattered in a loose cloud, never coalescing into something solid. Planets emerge because gravity gradually pulls together dust and gas, compressing it tighter and tighter until pressure and heat transform it into a dense sphere. Gravity played a crucial role in forming the layers of our planet as well. It didn't create random layers. Instead, it organized them based on density. Heavy elements like iron and nickel sank to the center, while lighter materials floated to the surface. This sorting process continues to influence how Earth operates today. But gravity's influence extends beyond shaping our planet. It keeps the moon in its orbit, tugs on our oceans to create tides, and maintains Earth's steady path around the sun. As you reflect on these forces, consider how they shape not only our planet, but also your own experiences. What connections do you see between these cosmic forces and your everyday life? Imagine a world without the delicate balance that holds our planet together. Without it, everything we know would unravel. There would be no orbit, no seasons, and no shield against the relentless vacuum of space. Let's take a moment to reflect on Earth's orbit around the sun. This path isn't a matter of chance. It is a stable, nearly circular route that requires a precise equilibrium of forces. The forward momentum of Earth's motion must perfectly counterbalance the sun's gravitational pull. If Earth were to move too quickly, it would hurtle into the vastness of space. If it were too slow, it would spiral inward, drawn closer to the sun. Fortunately, Earth's speed and position work in harmony, creating a near-perfect loop, a continuous fall that never truly ends. This stability is crucial, enabling long-term climate patterns and establishing a reliable framework for our seasons, daylight, and solar energy. Life has evolved to thrive within these cycles, all dependent on gravity performing its essential role. But it's not just the sun influencing Earth. The moon's gravitational pull causes the oceans to bulge, creating the tides we experience. Even the solid part of our planet shifts slightly in response to these forces, a phenomenon known as earth tides. Over long stretches of time, these subtle movements exert stress on the crust, ultimately shaping tectonic activity. As you consider these intricate connections, how do you feel about the forces that govern our existence? The universe operates in such a delicate balance, and you are an integral part of this grand design. Would you like to delve deeper into these concepts, or perhaps take a moment to ponder the wonders of our world? Imagine for a moment that gravity is not merely a force holding objects in place, but a guiding hand shaping their movements and evolution. Consider the tilt of Earth's axis, the very angle that gives us our seasons. This tilt is maintained, in part, by the gravitational interactions with the sun and moon. Without this stabilizing force, our planet might gradually tip or spin in unpredictable ways. Instead, gravity helps keep that tilt steady, fostering a predictable environment. It doesn't fix everything in place. Rather, it creates boundaries within which change can occur. Now, think about gravity's influence on a smaller scale. It plays a crucial role in everything, from the formation of mountain ranges to the flow of rivers. It pulls glaciers down slopes, directs rainfall into watersheds, and shapes erosion over time. The landscapes we admire, valleys, cliffs, and plains, are the result of materials moving slowly under gravity's influence. Even the growth of trees is guided by this force. Roots dig downward, while stems stretch upward, all thanks to tiny cellular mechanisms that sense gravitational pull. These effects, though profound, often go unnoticed because they happen gradually. Gravity is silent, it doesn't flicker or glow, yet its influence is constant, connecting every aspect of Earth's systems, from the rotation of the core to the drifting of clouds in the sky. As you reflect on this, consider how gravity shapes your own environment. What other subtle forces might you explore in your daily life? Let's take a moment to explore the human connection to gravity. Your biology is finely tuned to Earth's gravitational pull. The strength of your bones, the way your blood circulates, and even how you balance while standing all rely on this specific force. In low gravity, your muscles can weaken, fluids may shift, and your eyesight might change. This is why astronauts experience various effects in space. Their bodies are accustomed to a gravitational force of 9.8 meters per second squared. Without it, Everything must adapt. Imagine if Earth had a bit more mass. Gravity would be stronger, and perhaps our bodies would need to be shorter or more robust to cope. Conversely, if gravity were weaker, the atmosphere could become thinner, possibly drifting away over time. The size and mass of our planet are not just abstract concepts, they create the conditions essential for life on the surface. The atmosphere remains stable, water flows in its unique patterns, and humans and animals grow to certain sizes. Even the wings of birds and insects have evolved under these precise conditions. Beyond our planet, gravity continues to be a powerful force. It acts as the architect of the universe, holding galaxies together, influencing the motion of stars, and bending light from far-off objects. This bending, known as gravitational lensing, helps us detect phenomena we cannot see directly, such as dark matter. So as you reflect on your own existence, consider how deeply interconnected you are with the forces of nature. The very conditions that allow life to thrive are intricately linked to the gravitational pull of our planet. Would you like to dive deeper into the wonders of the cosmos, or perhaps take a moment to rest and absorb this knowledge? You may not see gravity, but you can certainly feel its effects all around you. Just like gravity, which influences everything that stands still or moves through space, there's a certain quiet order to the universe. It may not be perfect or mechanical, but it's a persistent force that shapes our reality. While gravity doesn't explain everything, it creates the conditions necessary for countless events to unfold. Without it, the world as you know it wouldn't exist. Now, consider water. At first glance, it might seem simple. 2 hydrogen atoms and 1 oxygen atom combine to form H2O. Yet water behaves in ways that elevate it beyond a mere chemical compound. It's everywhere on Earth, filling oceans, shaping weather, carving landscapes, and flowing through every living cell. Water is truly essential to life as we understand it. When you delve deeper into its properties, it becomes clear that water is anything but a mere coincidence. One remarkable characteristic is its ability to exist in all 3 states, solid, liquid, and gas, within the temperature ranges found naturally on our planet. This unique versatility is just one of the many reasons water holds a special place in the fabric of life. As you reflect on these elements, consider how they interconnect to create the world around you. Feel free to explore these thoughts further or take a moment to rest in the beauty of this complexity. You might not realize how unique water truly is. Unlike most substances, which tend to favor one state or need extreme conditions to change, water has the remarkable ability to freeze, melt, and evaporate within a narrow range of temperatures. This adaptability aligns perfectly with the planet's climate, but what makes these phase changes so significant? When water evaporates, it absorbs heat, effectively cooling surfaces around it. Conversely, when it condenses into clouds, it releases that heat, warming the atmosphere. This delicate balance plays a crucial role in distributing energy across the globe. It drives weather systems, regulates temperature, and prevents our climate from veering too far in any one direction. Another fascinating aspect of water is its high specific heat. This means water can absorb a substantial amount of energy before its temperature begins to change. As a result, oceans and lakes act as thermal buffers, absorbing heat during summer and releasing it in winter. This process smooths out temperature fluctuations that would otherwise be much more extreme. Imagine the difference in our environment if there were no buffering. Nights would be colder and summers would be sweltering. Perhaps the most intriguing characteristic of water is that it expands when it freezes. Unlike most substances, which become denser as they cool, water takes a different path. This unique behavior is just one of the many reasons why water is so essential to life on Earth. Wouldn't you agree that these properties make water truly extraordinary? As you reflect on this, consider how vital water is to our climate and ecosystems. Water is fascinating, especially when you consider its unique properties. As it cools down to about 4 degrees Celsius, it starts to expand. This remarkable characteristic causes ice to float. This trait has significant consequences for our ecosystems. It means that lakes and oceans freeze from the top down, forming an insulating layer that protects the water beneath. Life continues to thrive under the ice, allowing ecosystems to survive the winter. When the ice melts, it doesn't sink, preventing disruption to everything below. Another incredible aspect of water is its role as a solvent. Often referred to as the universal solvent, it can dissolve more substances than any other liquid, which enables it to carry minerals, nutrients, and gases through soil, rivers, and living organisms. Within your body, water facilitates the movement of substances in and out of cells, transports hormones, regulates temperature, and helps maintain structural integrity. The polarity of water is key to its functionality. With a slightly positive side and a slightly negative side, water can form hydrogen bonds. These bonds influence how proteins fold, how DNA maintains its shape, and how enzymes operate. These remarkable traits are not random. They stem from the angle of the H2O molecule, the distribution of its electrons, and the nature of the bonds involved. If any of these details were altered, even slightly, water would behave differently, perhaps becoming less flexible and less supportive of life. Isn't it intriguing how such small changes can have such profound effects? As you reflect on these properties, consider the vital role water plays in sustaining life on our planet. On Earth, water fulfills its essential role perfectly. What's fascinating is that water is quite common throughout the universe. Both hydrogen and oxygen, the building blocks of water, are abundant elements. Evidence of water exists in various forms: ice on moons and asteroids, vapor in comets, and potentially as liquid beneath the surfaces of certain planets or moons. However, what makes Earth unique is its large, stable quantities of water at the surface. Oceans cover about 70% of our planet, a remarkable feature that has persisted for billions of years. No other planet in our solar system can boast anything quite like this. Mars has ice and may have once harbored liquid water, but that water has long since vanished from its surface. Venus, too, may have once had oceans, but changes in its atmosphere boiled them away. The fact that Earth's water has remained neither freezing entirely nor evaporating indicates that the planet has maintained a narrow temperature range for an extended period. The origins of Earth's water continue to spark debate among scientists. One theory suggests that water was trapped in the minerals that formed the planet and was gradually released over time. Another possibility is that it arrived later, brought to our world by icy comets or asteroids. Isn't it intriguing to ponder the journey of water on our planet? As you reflect on this, consider how vital water is to life as we know it. You might wonder about the delicate balance of water on our planet. Regardless of how it came to be, the distribution of water has created vast oceans, sustained weather patterns, and supported a dynamic hydrological cycle. This cycle involves evaporation, condensation, precipitation, and runoff, constantly flowing between land, sky, and sea. It nurtures diverse ecosystems, nourishes forests, fills rivers, shapes coastlines, and gradually erodes mountains. Water transforms rock into fertile soil, carrying essential nutrients from one location to another. Imagine a world without this cycle. The earth would be barren, plants would wither, and food chains would collapse. Water is not merely a component of life, it is the very system through which life flourishes. Its interaction with light is equally fascinating. Water remains transparent within the visible spectrum, allowing sunlight to penetrate oceans and energize photosynthesis in aquatic plants. If water were opaque, underwater ecosystems would struggle in darkness. Fortunately, it filters harmful ultraviolet rays while permitting just enough light for life to thrive. Consider the various forms water takes: rain, snow, clouds, and fog. Each plays a crucial role in its constant movement, influencing temperature, visibility, behavior, and even your mood. Reflect on how essential this element is to our world and the intricate balance it maintains. You are invited to pause and appreciate the wonders of water and its vital role in our lives. You notice how animals migrate, how people cultivate their crops, and how landscapes transform. The timing of these patterns, the frequency of rainfall, the duration of snow, and the onset of dry seasons is intricately linked to factors like geography, air currents, and the tilt of our planet. Earth's climate and its water systems exist in a delicate feedback loop, one that currently sustains a rich diversity of life forms. Even in the depths of the ocean, far from sunlight, life thrives. Hydrothermal vents emit heat and minerals, creating entire ecosystems that flourish around them. Here, bacteria transform chemical energy into food, supporting fish, crustaceans, and unique organisms that you won't find anywhere else. These underwater realms remind you that life doesn't always rely on light, but it fundamentally depends on water. Isn't it fascinating that the most abundant liquid on Earth is also its most essential? A substance so simple in structure reveals itself to be remarkably complex in function. The conditions that keep water flowing, atmospheric pressure, surface temperature, and planetary mass, are all intricately connected. This doesn't imply that water was designed to behave in such a way. Perhaps life simply adapted to the characteristics water naturally possesses. Yet this perspective raises an intriguing question. Why does water behave this way in the first place? Why does a molecule composed of just 3 atoms serve as the foundation for a system that supports such an intricate web of life? Imagine a different universe where water might not exist, or where it behaves differently, or perhaps where it's replaced by some other medium entirely. What would that world look like? The possibilities invite you to reflect on the incredible role water plays in sustaining life as we know it. In this vast universe, water plays a vital role. It flows, carries, dissolves, freezes, and transforms, quietly supporting the processes that sustain life at every moment. When you take a closer look at the shapes life takes, how trees branch, shells curl, petals align, or crystals form, you begin to notice patterns. These patterns aren't just coincidences, they reveal a deeper repetition across different scales and environments. Some structures are symmetrical, while others spiral or fit simple numerical ratios. Although physical processes can explain these forms, the consistency they exhibit is striking. Symmetry is perhaps the most noticeable of these patterns. You can see it in faces, bodies, leaves, insects, and even snowflakes. When both sides of an object mirror each other, whether vertically, horizontally, or rotationally, we recognize it as symmetrical. This balance serves a purpose. It can enhance an organism's efficiency in movement or help distribute weight evenly. Yet symmetry also captivates our perception. Our brains are naturally inclined to recognize it quickly, and we often find symmetrical faces more attractive. This principle extends beyond nature. We incorporate symmetry into design, architecture, and symbols. As you reflect on these observations, consider how these patterns influence your own perceptions and experiences. Embrace the beauty of symmetry in your surroundings and let it inspire your understanding of the world. You find yourself drawn to the beauty of order and familiarity in nature. Symmetry often serves a vital purpose. For instance, a butterfly's wings are perfectly matched, creating a harmonious display. A starfish showcases radial symmetry, allowing it to navigate and adapt to its surroundings effectively. Leaves grow in pairs, designed to capture sunlight evenly. Even the structures of many viruses are symmetrically built, not for aesthetics, but for efficiency. This symmetry enables them to replicate using the same genetic instructions, providing a straightforward approach: create one piece and replicate it. Yet, not everything in nature adheres to this mirrored concept. Some of the most fascinating structures take on a spiral form. You can observe spirals in snail shells, hurricanes, whirlpools, and even galaxies. They appear in the arrangement of pine cones and sunflower heads, in fingerprints, and in the horns of animals. Spirals often signify growth, allowing structures to expand while maintaining their compactness. As an organism adds new material, be it a scale, a layer, or a petal, the spiral accommodates this growth without disrupting the overall form. Many of these spirals adhere to a mathematical pattern known as the Fibonacci sequence. This sequence consists of numbers where each new number is the sum of the two preceding ones. Isn't it curious how nature intertwines mathematics with beauty? As you reflect on these patterns, consider how they resonate with your own experiences. Would you like to explore more about the wonders of nature's designs? As you explore the world around you, you might notice fascinating patterns in nature. The arrangement of petals, the way tree branches split, and even how seeds are packed all reveal a sequence known as the Fibonacci sequence. This sequence elegantly approaches what we call the golden ratio, a proportion that appears in both nature and art. While it may not be universal, its presence is intriguing enough to draw your attention. These patterns emerge naturally, without any need for intelligence or design. Take, for instance, a plant that grows new leaves. In its quest to maximize sunlight for each leaf, it may develop a spiral arrangement. This spiral aligns beautifully with the golden angle, a fraction of a full rotation that allows for efficient distribution. No one intentionally created this beauty. It simply results from the plant's growth process. Yet the outcome is undeniably lovely. This is where the concept of sacred geometry often comes into play. Sacred geometry is a term that has been interpreted in various ways, sometimes spiritual, sometimes symbolic, and often poetic. It describes the patterns that seem to resonate with deeper meanings due to their very structure. You can find circles, triangles, spirals, and hexagons in religious art, ancient architecture, mandalas, and monuments. Each shape carries its own significance, inviting you to reflect on the beauty and harmony found in the world around you. You might notice that nature often reveals its beauty in patterns, like the delicate shapes of snowflakes, the intricate designs of honeycombs, and the stunning formations of coral reefs. This connection between the geometry found in nature and our human creations isn't just a coincidence. Perhaps we mimic what we observe, incorporating these familiar forms into our architecture and symbols because they resonate with us on a deeper level. Is it possible that we are instinctively drawn to certain shapes because they feel more complete, meaningful, or aesthetically pleasing? Take hexagons, for instance. Bees construct their hives using this shape, as it's the most efficient way to divide a space into equal sections while using the least amount of wax. This clever design not only results in a stable structure, but also showcases nature's ingenuity. You can also find hexagons in natural wonders like the Giant's Causeway or in the bubbles that form in foam. These same shapes arise from the laws of pressure and physics, independent of bees. Crystals provide another fascinating example. Their atoms organize themselves into repeating patterns, forming structures such as cubes, prisms, or even intricate branching shapes. These forms aren't simply crafted, they emerge organically, dictated by the fundamental interactions of molecules. Temperature, pressure, and chemical bonds all influence how these crystals grow, resulting in something that appears both random and intentional at once. As you reflect on these natural phenomena, consider how they connect to your own experiences and the world around you. Imagine standing in a serene forest where you notice fractals, patterns that repeat at different scales. Picture tree branches branching out into smaller twigs. Visualize rivers dividing into tributaries, lightning forking across the sky, and the intricate network of veins in your body. Each level mirrors a smaller version of the whole. Fractals are remarkable in their efficiency, distributing energy and resources in a way that allows a system to reach numerous points from a central core. They often arise from simple rules applied repeatedly, which is what makes these patterns so captivating. Complexity isn't a prerequisite for their emergence. Rather, they develop through feedback loops, constraints, and repeated processes. Even when they are not born from intention, these patterns exude a sense of purpose. They create a visual logic that feels too consistent to be purely random. There's an undeniable harmony in how these patterns interact. Consider how branches fill space without overlapping, how spirals pack seeds with precision, and how snowflakes grow along symmetrical paths. These outcomes aren't chaotic, they possess structure. As you observe enough of these structured outcomes, you may begin to wonder if structure itself is part of a deeper, more profound picture. Take a moment to reflect on this idea. What insights might it offer you? Some scientists propose that certain shapes, like spheres, spirals, or hexagons, are favored in physical systems. Given enough time and freedom, matter tends to adopt these forms because they are stable and efficient. This idea is intriguing, but it raises further questions. Why are these stable and efficient shapes also the ones we observe throughout the universe? Why do they support life? Why can we find them in both cells and stars? You don't need to invoke anything mystical to appreciate these patterns. Yet it's worth pondering why the universe seems to produce outcomes that are both functional and aesthetically pleasing. Why do the shapes that promote plant growth also resonate with our concepts of art and beauty? Why are the most effective structures the ones that appear most frequently? This observation doesn't imply a strict blueprint. There's no written plan or design document. Instead, it suggests a framework, a set of principles that guide what is possible, likely, and sustainable. Whether this framework originates from physics, mathematics, or something more abstract, it is clearly woven into how matter organizes itself. This interconnectedness is part of what makes the living world so captivating. As you reflect on this, consider how these principles might resonate in your own life. What connections do you see between the patterns of nature and your experiences? As you observe the outer forms of life, you might marvel at how seamlessly everything appears to fit together. Yet, when you delve deeper into the inner workings of a cell, the nucleus, the molecules that orchestrate life, you find that sense of harmony only intensifies. The intricate systems of biology reveal themselves to be not just functional, but also beautifully coordinated. The more you explore, the more it feels like something transcending mere chemistry. At the heart of it all lies DNA, or deoxyribonucleic acid, the essential molecule that carries genetic information. Every living organism known to us utilizes DNA, or its close relative, RNA, to convey the instructions necessary for its growth and maintenance. DNA is not merely a substance, it is a code composed of 4 types of molecules: adenine, thymine, cytosine, and guanine. It is structured in sequences that dictate how proteins are created. These proteins, in turn, power the very machinery of life. Often likened to a language, DNA possesses not only a limited alphabet, but also a rich structure, syntax, and meaning. A tiny alteration in a DNA sequence can change the shape and function of a protein, sometimes only slightly, and at other times dramatically. Remarkably, the same gene can be found in different organisms, serving similar functions while exhibiting small variations. Isn't it fascinating how interconnected life truly is? As you ponder these intricate relationships, consider how every element plays a role in the grand tapestry of existence. Imagine the intricate dance of information within every living cell. It's not merely a chemical reaction, it's a carefully orchestrated process. When you delve into the workings of DNA, you discover that its role extends beyond just storing information. It's about managing that information with remarkable precision. Consider the sequences within DNA that function like traffic signals, indicating when a gene should spring to life or take a pause. Regulatory genes oversee the activities of other genes, ensuring everything operates in harmony. There are also repair systems diligently scanning for errors during the copying process, ready to correct them swiftly. All of this remarkable organization occurs within a structure that is only a few micrometers wide, yet it exists in every cell of every living organism. This level of complexity prompts profound questions. It's not just about imagining how such a system could exist. It's about recognizing its astonishing effectiveness. The prevailing explanation is evolution through natural selection. Small genetic changes lead to variations, and those that enhance survival are passed on through generations. This gradual process gives rise to complexity, and the evidence supporting it is compelling. You can find it in fossils, laboratory experiments, and in the shared genetics among related species. Yet, even within this evolutionary framework, the mechanisms themselves are striking. Proteins fold into unique three-dimensional shapes, influenced by the interactions of their amino acids. This intricate unfolding showcases the beauty of life at its most fundamental level. As you reflect on this, consider how these processes contribute to the tapestry of life that surrounds you. Would you like to explore more about these fascinating mechanisms? Folding is crucial for the function of proteins. When a protein folds incorrectly, it often loses its ability to perform its role. Inside living cells, this folding occurs automatically, guided by the sequence of amino acids and aided by other molecules that act like chaperones. Remarkably, there is no conscious awareness involved in this process. Yet the system operates with a kind of elegance that is difficult to overlook, and where conduct are read, it is not a random trial and error. Rather, it involves thousands of moving parts working together in perfect harmony at just the right time. Now, think about enzymes, proteins that accelerate chemical reactions. Without these remarkable molecules, many of the reactions essential for life would occur far too slowly to sustain any organism. With enzymes, however, these reactions happen millions of times faster. Each enzyme is highly specific, fitting its target like a key fits a lock. Their selectivity is not just functional, it is vital for controlling when and how processes unfold in living systems. Then we have molecular motors, tiny protein machines that transport materials within cells. Some of these motors walk along cellular structures, carrying cargo from one location to another. Others spin, pump, or open and close gates. They transform chemical energy into motion, often mimicking mechanical devices on a grander scale. Can you imagine the intricate dance of these proteins, ensuring that life continues seamlessly? Every living organism, from the tiniest bacteria to the tallest trees, shares fundamental systems. Although the components may differ, the underlying principles remain consistent. This commonality hints at a shared origin, a concept that aligns with the theory of evolution, yet it also prompts a deeper inquiry. Where did those original instructions originate? Think about the first sequences, the initial proteins, the earliest membranes. The study of how life emerged from non-living matter, known as biogenesis, is an exciting field of research. Scientists have proposed various models to explain how the first self-replicating molecules might have formed in the conditions of early Earth. Some suggest clay surfaces, while others point to deep-sea vents or ice-covered lakes as potential catalysts. Despite ongoing advancements, no single theory has gained universal acceptance. The complexity lies in the fact that life demands more than just molecules. It requires intricate systems that can copy, regulate, respond, and evolve. While it's conceivable that these systems could gradually emerge from simpler forms, bridging the gap between chemistry and biology poses one of the greatest challenges in scientific modeling. As you reflect on this, you might find yourself wondering, does the intricate design of biology hint at a form of engineering? Imagine a world where every piece plays its role with remarkable precision. It's not just machines created by human hands, it's a profound dance of efficiency and adaptability. The code within living beings isn't merely data, it's alive, executing instructions, transforming, and evolving in real time. Consider the structure of DNA. If you were to stretch it out, human DNA would measure about 2 meters long, yet it fits snugly within a microscopic nucleus, coiled around proteins and folded into intricate loops. This organization allows the right genes to be accessed precisely when needed. This isn't chaos, it's a masterclass in management. Beyond the confines of DNA, cells are equipped with sophisticated feedback systems. These systems send signals that prompt growth, division, repair, or even death. They maintain balance within organisms, responding to damage, stress, hunger, and infection. Through chemical messages, these cells communicate, adjusting their actions based on ever-changing conditions. Mistakes are a part of this intricate dance. They happen, but the beauty lies in the system's resilience. Life doesn't hinge on perfection, it thrives on adaptability. While biology isn't without flaws, mutations can lead to disease, and systems can falter. The ongoing persistence of life, despite constant upheaval, showcases a remarkable form of engineering. It's not rigid, it's adaptive. It's not static, it's dynamic. As you reflect on this complexity, consider how resilience shapes not just life, but your own journey. Embrace the idea that growth often emerges from the most unexpected places. Would you like to explore this notion further, or take a moment to pause and reflect? As you delve into the world of biology, it's essential to recognize that cells were not necessarily designed by a conscious mind. Instead, the systems we observe may simply be those that have thrived because they work effectively. This idea is entirely plausible. However, when you consider the intricate coordination involved in these systems, the natural comparison expands beyond factories, cities, or machines. It leads us to think of a code base, a set of instructions that not only constructs itself, but also maintains and updates its own structure. Just like software, biology is composed of layers. At the foundation lies the raw code, the sequence of DNA. Then there's the operating system, the cellular machinery that interprets this code. Within this framework, you find inputs and outputs, error correction, and feedback loops. And there are also networks, intricate interactions between genes, proteins, cells, and organs that give rise to behaviors, responses, and even thoughts. This invites a shift in perspective. Rather than asking whether biology was engineered, we can ponder whether engineering and biology can be understood in similar terms. Is this comparison merely metaphorical, or does the structure of life hint at a profound connection between systems that evolve naturally and those that are intentionally designed? This question remains open, yet, as you explore life's code more deeply, you discover that it appears increasingly structured, not random or improvised, but layered, regulated, and intricately integrated. Take a moment to reflect on this. What insights might you uncover about the connections between life and the systems we create? Imagine for a moment that DNA is more than just a sequence of chemicals. Once you grasp that it functions like a code, it becomes easier to view it as a unique language. This language doesn't rely on words or grammar like the languages we speak. Instead, it operates with its own set of rules, an alphabet, and a syntax that conveys meaning. Written in a four-letter chemical script, DNA holds the essential instructions for building proteins and dictates when, where, and how these proteins should be produced. It's a physical repository of information, with directives embedded within matter itself. This raises an intriguing question. Was this language created, discovered, or does it exist somewhere in between? DNA is more than just a simple chain of chemicals. It's organized into genes, specific sequences that can be transcribed and translated into proteins. However, genes are only part of the narrative. They exist alongside regulatory regions, which serve as signals for the cell. These sequences determine when to start or stop reading a gene, how much of a protein to produce, and what conditions might prompt a change. Consider the enhancers and silencers, which can influence gene activity from afar. And then there are introns, segments of genes that get removed before the final product is completed. You might have heard of non-coding regions, often referred to as junk DNA. While this term is gradually falling out of favor, it's important to remember that these regions may play crucial roles in structuring the genome or affecting how genes are expressed. As you reflect on this intricate system, it's fascinating to realize the complexity and beauty of how life communicates at the molecular level. Would you like to explore this topic further, or perhaps take a moment to contemplate the wonders of genetic language? Imagine a world where code behaves not merely as a set of instructions, but as a dynamic programming language. This language encompasses not just commands, but also context, allowing for layering and conditional behavior. In the realm of computers, code is compiled and executed, while in living cells, DNA undergoes transcription and translation. Both processes rely on a system capable of interpreting symbols with precision, structure, and timing. When these rules are not adhered to, breakdowns can occur. Yet DNA does not simply await its turn to be read in its entirety. At any moment, only a small fraction of it is active. Different genes are activated in various cell types at distinct stages of development, responding to a multitude of signals. The same DNA sequence can yield vastly different outcomes based on its location within the body or the surrounding environmental conditions. This remarkable flexibility is a key element in the complexity of life, allowing DNA to transcend mere data. It operates as a sophisticated system. What's truly fascinating is that this system seems to be universal. Every known form of life on Earth employs the same fundamental genetic code, utilizing the same 4 letters, the same codon structure, and the same translation rules. A codon, for instance, is a combination of 3 bases that corresponds to a single amino acid. This interconnectedness underscores the elegance of life at its most fundamental level. As you reflect on this, consider the profound implications it has for our understanding of biology and existence itself. Imagine a world where there are 64 possible codons, yet only 20 standard amino acids. This intriguing redundancy in the genetic code reveals something remarkable. Some codons serve as synonyms, while others act as punctuation, signaling when to start or stop. This entire system is shared across bacteria, plants, and animals alike, hinting at a common origin. Can you picture a moment in the distant past when all life on Earth settled on one universal code? Every branch of evolution has carried this code forward, but it also prompts deeper questions. Why this specific code? Why this particular structure? Scientists have delved into whether the genetic code is optimized, exploring if it represents the best possible arrangement of codons to minimize errors while allowing flexibility. Some research suggests it is close to optimal, though not perfect. It efficiently reduces the impact of mutations and ensures robustness. If this is true, it implies that life didn't just choose any code, it adopted one that functions remarkably well. Does this indicate that the code was naturally selected, or that certain structures were more likely to endure? The perspective you take can shape your understanding. Regardless, what we observe today is a system that operates across all forms of life, thriving with variations for billions of years. And then there's the fascinating aspect of interpretation. While humans didn't create DNA, we have uncovered the secrets of how to read it. This discovery opens up a world of possibilities. What do you think about the journey of life encoded in these simple yet profound sequences? Imagine a world where chemical sequences transform into meaningful information. When we embarked on this journey, we uncovered something truly remarkable. It wasn't just complexity we found, it was logic. It wasn't merely molecules we encountered, it was instructions. This discovery has opened doors to entire fields of research, such as genetics, molecular biology, and bioinformatics. Today, we have the ability to manipulate DNA using tools like CRISPR, allowing us to redesign genes with remarkable precision. We can synthesize sequences, insert them into cells, and observe their functions. In many ways, we are beginning to write in the language of life. Yet, it's important to remember that we did not create this language. It existed before us. This brings us to the concept of design. DNA does not appear manufactured like a computer chip. Rather, it exhibits purposeful behavior. It processes information in ways reminiscent of software, logic circuits, or meticulously crafted instructions. It's not random noise. It possesses structure and output, embedded within every living organism. Then there's the question of meaning. In human languages, meaning stems from intention. When someone writes or speaks, they have a goal of conveying a message. However, with DNA, the meaning is not a product of conscious thought. Instead, it is functional. A sequence holds meaning because it triggers specific outcomes. As you reflect on this, consider the intricate dance of life encoded within these sequences. What insights might you uncover as you explore this fascinating realm? Imagine